So chapter 3, we're going to just have a look at the basics of this chapter. Please let me know if you have any questions about the information that you see in this video. So what is a sensor? So a sensor is an input device that records data about the surrounding physical environment. So just some examples of sensors. So you can get temperature sensors, humidity sensors. So generally what the sensor detects is usually the beginning term of that sensor. So a temperature sensor, for example, measures temperature. But you probably remember sensors from the IGCSE textbook. Let's go to the next slide. So what is meant by analog? So this is a smooth stream of data that we process on a daily basis. So just an image maybe that you saw from IGCSE. So we have analog data and digital data. So digital data is data that computers are able to read and understand. But analog data or analog information is data which is smooth. So you can see, for example, if we were to speak into a microphone, you would get sound waves. And this type of data is data that a computer can't understand. So you would need an ADC or an analog to digital converter to change the analog signal to digital data in order for the computer to understand. So analog is just a smooth stream of data that we process on a daily basis. What is a microprocessor? So that is an integrated circuit used in monitoring and control technologies. So we're just going to have a look at some definitions that you've got to know for this chapter. What is an actuator? So this is a type of motor that controls a mechanism or a system. So just in terms of like a greenhouse. So in a greenhouse you have light sensors, temperature sensors, moisture sensors, so that the plants in the greenhouse can grow at the best possible or grow in the best possible environment. So the sensors will send the information to a computer, and then depending on what the results or what the sensors picked up in that environment, the computer will then decide whether or not it has to change certain elements of that environment. So for example, if the temperature in the greenhouse is not high enough, the computer can then turn on a heater. So actuators, the actuators in this diagram here are lights, heater, water pump, and window motor. These are devices that are able to bring about a change to the environment. So these are examples of actuators. What is infrared? So you've probably seen an infrared photo like this before. So it's a wave of light emitted by an object that is invisible to the naked human eye. What is a microwave? An electromagnetic wave of energy. And there's not a lot of information about a microwave in your textbook, so I just went and pasted this image over here if you want to pause and have a look at the different properties of the different waves. So radio waves, microwaves, infrared, etc. But that is up to you. You don't have to. What is piezoresistance? It's a specific level of electrical charge that is linked to a specific level of resistance or pressure. So probably in the next video we're going to see how traffic lights, for example, use piezoresistance. What is humidity? So that's the amount of water in the atmosphere. What is a photoresistor? That is a light controlled resistor. So in the next video we'll also have a look at how photoresistors could be used in a traffic system. So what are the basic steps in a control system? So the basic concept behind most monitoring and control systems is very similar. They will normally go through the following steps. So firstly, so just think of like a greenhouse, for example, when you're thinking of a monitoring or control system. The sensor will constantly monitor the surrounding environment. The data readings from the sensor will normally be analog, therefore they'll be converted to a digital signal for a computer system to process. So they'll be needed to be converted to a digital signal. So that is done by an analog to digital converter. The digital signal is then sent to a microprocessor. The microprocessor processes the value and compares it to a preset value or range of values. And if the value is outside the acceptable range, the microprocessor will send a signal to an actuator to trigger any action that needs to be taken. So just to describe maybe a greenhouse in terms of what they've explained over here. So let's say, for example, in the greenhouse, you want the temperature to be at a certain temperature in order for the plants to grow in a optimal environment. So the temperature sensors will constantly monitor the environment in a greenhouse, and that information that is sent to the microprocessor will probably be in an analog form. So you'll need an analog to digital converter to convert the analog data into digital form for the computer or microprocessor to read. So the digital signal is sent into a microprocessor, so the microprocessor processes the value and compares it to the preset value. So in a greenhouse, you might have a temperature that you want that greenhouse to be kept at. That will be the preset value. So the current temperature in the greenhouse will be compared to that preset value. And if the value of the current temperature in the greenhouse is outside that acceptable range, or it's not near that optimal temperature, then the microprocessor will send a signal to an actuator, so like a heater or water pump, to trigger any action that needs to be taken. So like, for example, a water pump or a heater, depending on whether or not the temperature needs to increase or decrease, one of those will be activated, and then the temperature in the greenhouse will hopefully be returned or brought near the optimal temperature. So those are the 4 basic steps of a control system. What is the difference between a monitoring and a control system? In a control system, an action is triggered to control an element of the system as a result of the monitoring that is taking place. So for example, if you saw in the greenhouse, like the temperature was being controlled by the system. A monitoring system outputs results in a different way. So rather than action being triggered in a monitoring system, the results of the readings taken from the monitoring can be output in the form of graphs or charts. This allows the readings to be compared and any patterns or trends to be identified. This information can then be used to inform any future decision making. So in a control system, you sometimes have like actuators that can control the environment, but in a monitoring system, all you're doing is gathering information about that environment. A monitoring system can be used to monitor scientific experiments. How is this better than to use humans to monitor? So this kind of technology removes the need for a human to regularly take the readings. This means that the readings can be taken over long periods of time and can often be more accurate if taken by a system. So these are just some reasons why you would want a monitoring system to monitor scientific experiments than humans. What is the difference between a passive and an active motion sensor? So motion sensor detects movement. There are 2 ways in which it may do this, actively or passively. A passive motion sensor reads the energy in its surrounding environment and detects changes caused by movement. However, an active motion sensor emits energy into the surrounding environment to detect any movement. So an example of a passive motion sensor is a passive infrared sensor. This is a sensor that detects the presence of infrared energy if it appears in its surrounding environment. An example of an active motion sensor is a microwave sensor. So this is a sensor that emits microwaves and detects the changes in the reflection it receives back when bouncing off nearby objects. So an active motion sensor, it is a sensor that emits energy into its environment, but a passive sensor does not do that. Where are passive motion sensors used? So passive infrared sensors are commonly used in security systems. These sensors are normally wall mounted in the corner of a room. As an intruder walks in front of a sensor, the sensor detects the infrared energy emitted by the intruder. The detection of the infrared energy by the sensor can then trigger an alarm to sound. Okay, so in security systems. Where are active motion sensors used? So also in terms of security systems, but in the terms of an active motion sensor, a microwave sensor continuously emits microwaves into a room. as an intruder walks through the microwaves, they will be reflected back much more quickly to the sensor, and it will detect the change. This change in reflection of the microwaves can then cause an alarm to sound. So that's how active motion sensors can be used in terms of security systems. Name other areas where motion sensors can be used. So motion sensors can be used in lots of other monitoring and control systems. So these include CCTV systems to maneuver the camera to the direction of motion that is detected, opening and closing automatic doors, automatically turning lights on or off in a room when a person enters or leaves, automatically turning water taps on or off, and automated barriers in a car park. So these are just some areas where motion sensors can be used, besides security systems. I hope that was alright. Please let me know if you have any questions.